My name is G. Mahendraswaroop. I am from CSM department. I am going to teach about distributed system in the time and clock. In the topic is synchronization physical clock. So synchronization physical clock. So here first topic is external synchronization. A computer's clock CA is synchronized with an external authoritative time source S, so that here the computer clock means here computer clock CI is synchronized with an external time source, that is S, so that here SI S of t minus Ci of t less than or less than d for all I is equal to 1 to n, overall for interval of real time t in I. Here the clock Ci are accurate to bond D, within a bond D. Here the clock Ci is accurate with a bond D, and so external synchronization means the computer clock Ci is synchronized with an external time source S, and that formula is S of t minus Ci of t less than d for I is equal to 1 to n. So internal real time is t in I, and the clock Ci's are accurate bond with d. And internal synchronization, the clock of the pair of computers are synchronized with one another, that is Ci of t minus Cj of t less than d for all I comma j is equal to 1 to so on n, for interval real time t in I, and the clock Ci and Cj are bonded with d. Here the clock Ci and Cj are bonded with d, so that's why Ci of t minus Cj of t is less than d for all I comma j is equal to 1 to 3 so on n. So here it is bonding with d. Internal synchronizations are not necessarily external synchronized, and if the set process P is synchronized with the bond D, it also internally synchronized with bonded 2D. So here the set process P is synchronized with the external bond D, means here the process P is synchronized with the external bond D, means it is also bonded with internal synchronization 2D. So process P is synchronized with D means it should be internally synchronized with 2D also. Next, clock correctness. So here hardware clock H is said to be correct if it is drift rate within a bond P greater than 0. Example, that is 10 to the power of minus 6 seconds per second. So here hardware clock H is said to be correct if drift rate within the bond P greater than 0. For example, that is 10 to the power of minus 6 seconds per second. This means that error is measured, the interval between the real time t and t dash is bonded, means here the error measure must be between the t and t dash, means 1 minus p into t dash minus t less than or equal to h of t dash, means here h is hardware clock, h dash minus h of t less than or equal to 1 plus p into t dash minus t, where t dash greater than or equal to t, means here the error measure of the interval between the real time t and t dash is bonded. For that formula is 1 minus p into t dash minus t into t dash minus t less than or equal to h of t dash minus h of t less than or equal to 1 plus p into t dash minus t, where t dash is greater than t, means here jumping the time reading from hardware clock. Here it is jumping the time from the hardware clock. So here weaker condition for the monotonicity may suffer from t dash greater than t implies t of t dash greater than c of t. So here t dash is greater than t implies c of t dash greater than c of t. Here it can achieve the monotonicity with the hardware clock that runs faster by adjusting value, that is alpha and beta in Ci of t is equal to alpha of h of t, hi of t plus beta. Means here alpha and beta in Ci of t is equal to alpha hi of t plus beta. Here a faculty clock, a fault clock in one that does not obey the correctness condition. Here a fault clock one does not obey that the correctness of the condition. And the crash fail, here clock stops the tracking. Means crash failure means here clock will be fail when it is crash. Arbitrary failure, any other failure, example jumping in the time. Means here failure may occur anything anyway, but not a jumping in the time. Like here any other failure, like example is jumping time, not other. And synchronization in synchronization system. Here synchronization distributor system is one which that follows the bonds are different, like the time to execute each step of the processes has known lower and upper boundary. Next, each message is transmitted over a channel is received within known boundaries time. Each process has a local clock whose drift rate real time has no bounded. Here we are having three types of bounds in different defined. Here it is defined. That is the time to be executed each step of the processes has known, that is lower and upper boundary, and each message is transmitted over a channel is received within a bounded time. Means here it should be within a bounded time. Each process has a clock whose drift rate is real time has known boundary. And internal synchronization in synchronization system. Here the processes, one process P1 sends its local time T to processes P2 in a message M. Means here one processes P1 is sending a local time T to processes P2 in a message M. So here P2 could set its clock to T plus T transmit, where T transmit is time to transmit. M means here time T is transmitting to transmit M. T transmit is unknown, but minimum is less than or equal to T transmit less than or equal to max. Means here minimum can be measured or means here minimum can be measured or conservative estimated, and maximum in synchronization system. So here minimum can be measured or conservative estimated and maximum known in synchronization system. And uncertainty u is maximum minus minimum into setting the clock t plus maximum minus minimum by 2. It can skew less than or equal to u by 2. Means here maximum minus minimum by 2, that skews less than or equal to u by 2. System method in 1989 for synchronization system. Here external synchronization, that is a time server S receives signals from UTC source. A process P requests the time in MR and receives T in MT from S. So here S means server and P means processor, and requesting the time in MR and receiving T from MT. So here processors P set the clock to T plus T bond by 2. T round by 2 means here P sets the clock to T plus T round by 2. Here accurate plus or minus T round by 2 minus minimum. Here T round is round trip time recorded by processes P, and minimum is estimated minimum round trip time, and wrong means minimum schedule be only be one way trip time means here wrong means here minimum should be one way trip time, because the earliest time S puts T in message MT is minimum after P sends MR. Here MR means time. The latest time was minimum before MT arrives at processes P. Here the time by server S clock when the time TMT arrives is in the range of T plus minimum comma T plus T round minus minimum. Here the formula is T plus minimum comma T plus small t plus T round minus minimum, and the width of the range is T round minus 2 minimum. Here the width of the range is T round minus 2 minimum. So here accuracy is plus or minus T round by 2 minus minimum. So here we are having the processes P and server S, and sending the message and receiving the message. Sending the message, that is MR, and receiving the message, that is MT. And Berkeley algorithm. Here Cristian algorithm. So a single time server might fails, so they can suggest the using of the group of synchronization servers. So here any single server is failed, so that it is suggesting that use the group synchronization server in the case of single server is failure. So it does not deal with the fault server. So here it will not use the false server, it will use the alternate grouping synchronization server. And Berkeley algorithm as 1989, here an algorithm for the internal synchronization of group of computers. A master pole to collect clock values from the other, that is slave, and the master user round trip time to estimate the slave clock value. So here master use the round trip time to estimate the slave clock value, and it takes an average estimating by any above average round trip time or with the fault clock time. It sends the required adjustment to the slave, that is better than the sending the time when the depending on the round trip time. So here the measurement is 15 computers. A clock synchronization is 20 to 25 million seconds. Its drift rate is less than or equal to 2 into 10 to the power of minus. If master fails, can elect a new master to take over. So if a master fails, it can elect new master for taking a charge over. Network time protocol, NTP. NTP means network time protocol. Here system method and Berkeley algorithm are intended for intended. Here NTP means network time protocol, a time server for internal synchronization client to UTC means universal time coordinator. So reliability from redundant path, scalable authentication time source. So the synchronization subnet can reconfigure it failures occur. Example is a primary that loses its UTC source can be become secondary. Means here primary will be lost UTC source can become the secondary. Means if primary is lost, the secondary can be the it become an secondary. Means primary become the secondary, and the secondary losses, if secondary will be lost, it will become the primary can be use another primary. So here the primary losses UTC source can become the secondary, but if secondary losses, the primary can be used another primary. So here primary server can be connected to UTC server, and the secondary servers are synchronized to primary server. So here primary servers are connected to UTC sources, means universal time coordinator, and the secondary servers are synchronized to primary servers, and the synchronization subnet, and the leave server the lowest server in the user computer. Means here we are having the tree, that is first one tree, second one 2, these are the nodes for the one, and for 2 we are having 2 nodes, that is 3, and another 2 we are having the third node. First one is the primary, first one, the circle one is a primary source are connected to UTC source, and the second line, that is second, for first one second node, that is secondary servers are synchronized to the primary server, and third node, that is synchronization subnet or leave server level, low level server in the user computer. And NTP synchronization of server. Here we are having 3 models of synchronization, that is multiple cast, procedure call, and symmetric. Multicast means a server within a high speed LAN local area network multiple cast time to other. So here server within high speed LAN multicast time to other, which set the clocks assuming some delay, not very accurate. So it may be delay but not accurate. That is multicast. And procedure call. A server accepts the request from the other computer like system algorithm, and high accuracy useful if no hardware multicast. So here high accuracy will be used when there is no use of the hardware multicast, and that is procedure call. Symmetric. Here symmetric means pair of server exchanges messages containing time information. Here the pair of server exchanges the messages contain the information, means so use client to server, server to client, the messages will be exchanged. That is a pair of server. Here user where very high accuracies are needed. Here the user having the very high accuracy are needed. Example is higher level. So in this network time protocol synchronization server, we are having 3 model synchronization, that is multicast, procedure call, and symmetric. Multicast means a server with a high speed LAN multicast time to others, which sets the clock assuming some delay but not an accurate. And second one is procedure call. The server accepts the request from other computer like Cristian algorithm. Here high accuracy uses if no hardware multicast. Means here instead of higher multicast, hardware multicast, we use the higher accuracy. And third one, symmetric. The pair of server exchanges the messages containing the time information. Here the messages server to client to server, server to client, sending the messages or exchanging the messages, that time will be maintained. And here user very high accuracies are needed. Example is higher level. And next one is message exchanging between pair of NTP pair, means network time protocol. Here all modules uses the UDP, user datagram protocol. Each message bears timestamp of recent event, means here the message will be bear of the recent event, which event occur, the time will be maintained, like local time of sending and receiving of previous message and local time of sending of current message, means it will be store the previous message and it will store the recent sended message. And the receipt noted the time of receipt t1, we have ti minus 3 comma ti minus 2 comma ti minus 1 comma ti. So here receipts noted the time of the receipt, that is ti, where we are having the time receipts that are ti minus 3 comma ti minus 2 comma ti minus 1 comma ti. In symmetric mode, there can be a no negligible delay between the messages. Here there will be no negligible delayed messages, means here it will be send the message continually. Like example, we are having server A and server B. Here the server B is sending the message to server A, and server A will be send the message from ti minus 3 to ti minus 2, and from ti minus 2 to ti minus 1 it will send message to ti, and from ti to time it will send the message continuously, no delay will be there. So thank you.